Hi, my name is Andrew Snyder. I'm a system sales engineer with Lutron Electronics. In today's session, I'm going to be talking to you about the Vive wireless lighting control system and emergency lighting, including a brand new feature that we launched in November 2020 that makes emergency lighting even easier. This video assumes that you're already familiar with the basics of a Vive system. If you're not, there are great overview videos for Vive on Lutron.com and on Lutron's YouTube channel. The Vive system can be used to meet even the most stringent energy codes, and those energy codes often require emergency lighting. The Vive system can do emergency lighting in one of three ways. Number one, using emergency bypass relays. Number two, using the red UL924 emergency PowPak. And number three, using a contact closure on the back of the Vive hub. So let's look at each one of those. This demo here shows emergency lighting solution number one, using emergency bypass relays. One of these relays is required per zone of emergency lighting. We've got two zones of light here, one dimmed zone of light with 3 fixtures controlled by a Maestro dimmer, and one switched zone of light with 8 fixtures controlled by a Maestro switch. Within these zones, some fixtures are labeled as emergency fixtures with the black and white squares. These switches at the bottom indicate the presence of normal utility power, the presence of backup emergency power, and a currently deactivated fire alarm override. When utility power is lost, all emergency fixtures go to their emergency lighting level, and they cannot be controlled by the devices on the wall. When utility power is restored, the lights go back to whatever level they were at previously and can again be controlled by the devices on the wall. Emergency lighting solution number two is the red UL924 emergency PowPak. By building software intelligence into the PowPak itself, we've alleviated the need for emergency bypass relays. During normal operation, the red PowPak operates just like a green PowPak. So for example, this Pico remote is programmed to turn them both off. But when utility power is lost, it operates a little differently. Let me show you. These two power strips are powering everything in my Vive system. This black power strip represents normal utility power, and the white power strip represents normal/emergency power, which is only powering my emergency fixture. To simulate a utility power loss, I'm going to cut power to everything in the system, and a few seconds later, the backup generator will kick back on, turning on my emergency fixture. During this utility power loss situation, the emergency light will be set to its emergency lighting level and everything else in the system will be powered down. When in this state, the PowPak will ignore any controls that try to override the current lighting level. Then, when utility power is restored, the system will resume normal operation. Now there's one important note to be aware of when using emergency lighting solution number two, and that the red PowPaks require a power blip when transitioning from normal power to backup power. This makes them ideal for use when you're using a backup power source like a generator that has an inherent power blip when transitioning power. If you have a backup power source such as an inverter or a battery backup that doesn't have a power blip, then use emergency lighting solution number one or this next one that I'll tell you about. The third method of emergency lighting in the Vive wireless system is utilizing the contact closure input on the back of the Vive hub. Devices that are wired to this contact closure input can do two things. They can send any load in the Vive system to a pre-programmed lighting level, and as an example, I've set up a scene here that sends all lights to 100%. Also, this can be used to lock out controls from affecting the red emergency PowPaks. Now this feature is especially useful in two applications. Number one, fire alarms when wired to a fire alarm control panel. And number two, emergency lighting when wired to a Lutron emergency lighting interface, the Lut ELI. The Lut ELI will monitor normal utility power and it will send a contact closure input signal to the Vive hub when utility power is lost. Note that the control lockout functionality is supported on the red PowPaks, whereas the scene activation functionality is supported in all Vive load controllers. And that's an overview of emergency lighting in the Vive wireless lighting control system. Solution number three is brand new, so all new hubs shipped from Lutron will have this functionality. If you have an existing project that would like to implement solution number 3, you can download the latest Vive Hub firmware for free on Lutron.com, and you can deploy it on site. So emergency lighting can be tough. If you need additional help, check out the Vive Emergency Lighting Application Note, number 628 on Lutron.com, and reach out to your local Lutron representative for help with your next project design that includes emergency lighting.